angle B plus angle D. Okay, so this angle B plus angle 1, angle B, okay, this is 1 plus 2, angle 1 plus angle 2 is equal to 180 degree. Why? Because this angle B we have taken equal to 180 degree. Only angle D plus angle 3 plus angle 4 is equal to 180 degree for these two angles. Okay, so it means if I take these difference of these two angles, that side 180 minus this, angle B is equal to 180 minus sum of these two angles, angle 1 plus angle 2, and angle D is equal to 180 minus angle 3 plus angle 4. Alright, is 360 degree. Sum of these two, if I take angle B plus angle D, 360 degree minus these angles plus this angle, opposite angle sum. That means this is angle C plus angle B. Angle C plus angle B. That is 2. So angle C plus angle B, angle C plus angle A. We see here that sum of all the 4 angles is 360 degree. Therefore, sum of this angle 2 plus angle 3 plus angle 1 plus 4 equal to 180 degree. The sum of these two is also 180 degree. Because this way we can prove this, but proof is still I'm discussing about this article later. But in this way we can prove this. Okay, so this is about cyclic coordinators. Now let me talk about what is the second part. Parallelogram. If I take a rhombus, if I take first parallelogram or trapezium first. First is trapezium. Trapezium is of what kind? If two opposite sides of a quadrilateral are parallel but not equal, are parallel but not equal. They are parallel but not equal. Then the shape formed is a trapezium. What is trapezium? So this is the non-equal sides. Now this is parallel to this. Sides, let me take A, B, C, D. In this way I have taken clockwise or anti-clockwise we can take, no problem. Where AB is parallel to CD or DC. AB is parallel to DC, take DC. We can take AB, CD. AB is parallel to DC. Or AB is parallel to DC. These two sides are parallel here. Now these are the two non-parallel sides, this side and this side. AB is for this BC and AD is not parallel to BC, or we can write here is not parallel to BC. AD is not parallel to BC. This is formed as a trapezium. So trapezium is having one pair of opposite sides parallel, but they are not equal. So if we make them equal, and other two sides will also be parallel. Okay, so in that situation, if they are equal, then it will form a parallelogram or something else. Because in that situation, the other two sides will also be parallel or equal. These two sides are equal. So in the trapezium, one pair of opposite sides is parallel but not equal. So this is what trapezium is. Now what is area of this? We will just calculate that later. But that is one of the points here. Okay. Then if there is another side which is parallel, some facts regarding this. There is the midpoints of these non-parallel sides and they are meeting. Okay, and these are, let me take midpoints here. If midpoints of non-parallel sides, these are facts regarding this non-parallel sides of a trapezium are joined. Of a trapezium are joined. These are midpoints of non-parallel sides. This is midpoint here of this AB. And take this is E and this is F here. So EF then will also be parallel to this. Okay. Then EF will be parallel to DC and AB. So this side is also parallel to this. Then they are transversal lines. The ratio of this upon this equal to this upon this. You can say like that. Okay, then these transversal lines are intersecting. So then AE upon AD, we can say upon AD is equal to BF upon BC. We can say, or we can take AE upon ED. This ratio will be equal to BF upon FC. So in that way, this line, these three lines are parallel. Okay, this AB parallel to EF is parallel to DC. If midpoints are joined, then they are the midpoints of these two sides, and their ratio will be similar. This upon this equal to this upon this, or this upon this whole equal to this upon this whole. This parallel sides is then dividing. So these are the transverse lines then. When transverse lines are joined, then we can say that this is what we can take if the midpoints are joined. In case of trapezium, this is one of the required. Okay, we will find out the area. Then we joined this. Diagonals are then joined. Okay, area of the, then we have to calculate area of this triangle plus area of this triangle. We have taken base. We have these two sides and one of the diagonals here. Okay, D1 plus D2 we say for this side, parallel sides are added. CD plus this, half of CD plus this upon perpendicular distance, and then perpendicular distance will be the perpendicular from here, the right angle here, or from this also we can draw perpendicular. Okay, so this is the height of the trapezium. Because height, what is the height? Perpendicular distance between two parallel sides is the height of the quadrilateral. Okay, so if I take this height and this is the triangle, let me take. Okay, what is the area of this triangle? BCD. This will be half base BC into height H. Similarly, what is the area of this triangle? So this is height of this triangle also. So H is the height again, because this is the base. If I take this as the base and perpendicular height is this, which is H only. Then this half base is AB in that situation, AB into H. What is area? AB, half AB into H, half CD into H. Take half H common, then AB plus CD. So sum of the two parallel sides into distance between them H into half or into 1.2. That is the area of the trapezium. So that is another point. We will talk about area, perimeters, etc. of these figures, these sides in next lecture series. So up to this is trapezium we have talked about. This is trapezium. Then second is what is rhombus. Sorry, second is rhombus. Okay, let me take rhombus. In case of a rhombus, or let me take first parallelogram, because here cycle quality we took, trapezium we have talked about. Now rhombus, let me take. What is rhombus here? In a rhombus, okay, if a quadrilateral if a quadrilateral is having all the four sides equal, all the four sides equal, all the four sides are equal, but diagonals are not equal. But their diagonals are not equal. For example, if I take now this is side A, side A, side A, side A. The diagonal is bigger, the diagonal is smaller. Let me take A, okay, anti-clockwise, A, B, C, D. This is a rhombus here. In the case of rhombus, the two diagonals are not equal. Because if diagonals are equal, then it will become a square. Difference in a square and a rhombus is, in rhombus also we have all the four sides equal. In case of a square also all the four sides are equal. A length of the sides are equal. In case of a square and as well as in a rhombus. But in rhombus, the diagonals are not equal. Suppose this diagonal is AC is a D1 length, this is D2 D1. Length is D2 and this is D1. Different lengths are there. Then it is a rhombus here. Okay, then it is a rhombus. Now in this case, these two sides may be parallel. So they are perpendicular bisectors. I mean these diagonals bisecting each other or bisecting each other at right angles. Diagonals are bisecting each other at right angles. Bisecting. This D1 to D1 by 2, this is D1 by 2, D2 by 2, D2 by 2. That is there. Okay, that is one of the points. But diagonals are not equal. So, if in a quadrilateral, if a quadrilateral is having all the four sides equal, diagonals are not equal, then that forms a rhombus. That forms a rhombus. This one is a rhombus here. Now these two sides are not parallel, but opposite sides may be parallel here. This is parallel to this, this is parallel to this. But diagonals are not equal. Okay, this is regarding rhombus. What is area of the rhombus being calculated later? Okay, but if I take area, okay, of this, and these are two sides here. So this height and this is the base here. So the first D2 diagonal is the base, and this D1 by 2 is the height in this situation. Okay, so that is half D1 into D2. The area of this is half D1 into D2. Why? This is D2 area of a diagonal, because this area will be same. So in this situation also the height is same D2. And this D1 by 2 is the height in this of this triangle. Area of this triangle is half base into height. So half base is D2, height is D1 by 2. This is 1.4 D1 D2. But this area and this area are similar, so twice of this area is 2 into 1.4 into D1 D2. And this is 1.2 D1 D2. Area of the rhombus is half D1 into D2. That is one of the points. Okay. Now, if we have to find out value of D1 in terms of side, that can be calculated. That's not a problem. But the point is that how we have calculated this. The area of rhombus is this. Area of a rhombus. This we will take later, but just to remind you that this is half D1 into D2. D1 D2 are the length of the diagonals. This is diagonal AC, BD. To D1 we have taken this diagonal first, this diagonal second. D1 and D2 length of diagonals into 1.2 or divided by 2. This is the area of the rhombus. Rhombus is having all the four sides equal. Okay. It is just like a square, but in a square we have the diagonals, equal diagonals in case of a square. Okay, well, each angle is 90 degree. This angle may not be 90 degree. This is not 90 degree, not 90 degree. Okay, but in case of a sphere, we have each angle 90 degree. All sides are equal. That is another point. Because of that, opposite sides are parallel and equal. Okay, well, all the sides are equal. In case of rhombus, as well as in a square, but difference is that here diagonals are different, their diagonals are equal. Okay, this is about rhombus. Let me talk about what is rhombus. We talk parallelogram. What is a parallelogram here? In case of parallelogram, this is the point here. Parallelogram. Parallelogram. What is special about parallelogram? In parallelogram, opposite sides are parallel and equal, but all sides are not equal and parallel. Okay, the opposite sides of a parallelogram are equal and parallel. This is parallel to this. This is parallel to this. Opposite sides are equal and parallel to each other. So this is, but in case of this, opposite angles are equal. This angle equal to this. This angle equal to this. Okay. In case of parallelogram, the definition in a parallelogram, opposite sides are parallel and equal, but all sides are not equal. All sides are not equal. It is opposite sides are equal. All sides are not equal. I mean, opposite sides are equal, and but this is equal to this, this is equal to this. But and opposite angles are equal. Opposite angles are equal. The second condition, the first condition, are equal. But this angle equal to this. This is 1, this is 2. And sum of 2, this is not consequent angles of, okay, we can say the, okay, this is not consecutive angles, so this is 1 plus 2, this angle 1 plus angle 2 is 180 degree. This plus this is 180 degree. Okay, so we can say that 2 consecutive, this one is consecutive, two opposite angles are equal. The third point is sum of 2 consecutive angles is 180 degree. Opposite angles are okay, equal. This angle is this equal to this. This is angle 1, 1. This is angle 2. Okay. Opposite angles are equal, but sum of 2 consecutive interior angles. You can say 2 consecutive interior angles. Let me write here interior angles. Interior angles is 180 degree. Sum of this plus this 180 degree. Why this is there? Because now this angle is 180. This is this 180. Reason is, if this angle equal to this equal to this. Sum of this angle plus this plus this. So twice angle 1 plus twice angle 2 twice equal to 360 degree. Therefore angle 1 plus angle 2 equal to 180 degree. This angle plus this angle 2 is 180 degree. Two consecutive interior angles sum is 180 degree. This is what regarding parallelogram. Okay. Diagonals are not equal in this case. Diagonals are different. Okay. But opposite sides are parallel and equal. Opposite angles are equal in parallelogram. And sum of 2 consecutive interior angles is 180 degree. As I have just proved that angle 1 plus angle 2 is equal to 180 degree. Consecutive interior angles, sum of 2 consecutive interior angles is 180 degree. This plus this 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 is 180 degrees. Any two consecutive interior angles. Okay, one after the other. Consecutive means one after the other. Angle 1 plus angle 2, 180. Angle 2 plus angle, this one I have taken, but this suppose 1, 3, 4. and angle 1 plus angle 180, 2 plus 3 angle is 180, 3 plus 4 angle is 180, 4 plus angle 1 is 180. This is what consecutive integer angles is 180. This is regarding parallelogram. Okay, and these diagonals are not equal. They are different here. Area we will calculate area and perimeter. What is area and perimeter of this? That we will talk about next lecture series. This is just introduction. The facts regarding all these four-sided figures that I'm talking at the moment. Okay, this is about parallelogram. Okay, now next is a rectangle. Now here, this is just like a parallelogram. Rectangle is this is D point here or E point here. Rectangle. In rectangle also, opposite sides are parallel and equal, but all angles or each angle is 180 degree, or all angles are equal. All angles are equal, and they are equal to 90 degree. Means each angle is 90 degree are equal. That is, each angle is 90 degree. And that here angle, each angle is 90 degree. Okay, so parallel sides, opposite sides are parallel and equal. Parallel to this is parallel to this side equal to this side equal to this. Opposite sides are equal and parallel, and each angle is 90 degree. So difference between parallelogram and rectangle is rectangle. In this case, these two angles, sum is 180. Undoubtedly in parallelogram also we are having sum of two consecutive angles is 180 degree. Opposite angles are equal also here. The same condition as a parallelogram are proved here, but in this case each angle is 90 degree. There each angle is not 90 degree. Sum of two consecutive integer angles was 180 degree. Undoubtedly here also 90 plus 90 180, 90 plus 90 180, just like a parallelogram. But in parallelogram we are having, okay, not diagonals are not equal. In this case diagonals are equal. This diagonal equal to this diagonal. This is second difference. Okay. In diagonals are equal. In a rectangle are equal. Second is every angle is 90 degree. Every angle is 90 degree. Third point, opposite sides are equal and parallel. Opposite sides are equal and parallel. This is and parallel. Same condition as of parallelogram. This condition, but every angle 90 degree is different. Diagonals are equal. This is different from parallelogram. Okay, and then diagonals are equal. The sum of two consecutive integer angles is undoubtedly 180 degree, and yes, the fourth point we can write that constitute sum of consecutive integer angles is 180 degree. That is the same as sum of. This is I mean not a necessary point because it's fact here. Sum of two consecutive interior angles is 180 degree. There also in case of parallelogram, the same condition is there. That sum of two consecutive interior angles is 180 degree. Okay guys, so the last point is clear regarding square. I'll talk about after 5 minutes time. But then the camera is fully here. Okay, so that I'll take later after 5 minutes. Okay, then see you.